Okay, second half of chapter 4. We're on the home stretch here. 4 chapters down, fundamentals of arithmetic. So, chapter 4, fractions, decimals, and percents. So, here's where we left off. So, we need to look at then subtracting fractions with common denominators. In subtracting fractions with common denominators, then, as we've seen before, 8 and 8 are good. So, I can subtract 3 from 7 and do the reductions, and boom, I've got 1/2. Lowest common multiples. When adding or subtracting fractions, it's often necessary to find the lowest common multiple of a number that makes up the denominators. The lowest common multiple of 2 or more numbers is the lowest multiple that is common to each of them. So to find these then, we factor each term. We determine the maximum number of times a prime factor appears in any one term, multiplying the resulting prime factors found in step 2. This becomes the lowest common multiple. The lowest common multiple of several numbers then is the lowest multiple of each number that is common to all numbers. So this is something that we need when we are doing operations on fractions, so that we know we've got the lowest number in the denominator that we can handle. So let's start with just calculating lowest common multiples. What is the lowest common multiple of 6 and 8? So we're doing a comparison here. Let's find all of the factors in 2 and all of the factors in 8. So when we do, we know down to primes, 2 and 3 is as far as we can go for 6. On 8, we've got 3 2's, 2 cubed, or 2 times 2 times 2. So now what we've got to do is look at what is a multiple of these two numbers, 6 and 8, that we can factor down and turn it into a lowest common multiple. So the maximum number times 2 appears as a factor is 3 times. That's the maximum. That's in the second term, 8. So therefore, 2 times 2 times 2 is part of the lowest common multiple. 3 appears a maximum of 1 time. So therefore, 3 is part of the lowest common multiple. So you see that 8 has 3 2's in it. So that, that makes it such that we have to use all of those 2's. There's only 1 2 in 6, but there's 1 3 that doesn't show up in 8. So now we've got 2 cubed and 3. So this takes care of all the prime factors. Our next step then is to multiply, hence multiples, multiply these factors together to get the lowest common multiple. So the 3 2's times 3 gives us 8 times 4, or 24. So for 8 and 6, the lowest multiple between them is 24. When the fractions we are adding or subtracting have unlike denominators, we cannot add them directly as before. So we've got to find a common denominator. Okay, when we start doing, as you saw in that previous problem, these values where we're using reciprocals for resistance and conductors, sometimes we got to find common denominators. So the next rule, 4.4, says to add or subtract fractions that have denominators that are not alike, we have to find that common denominator. Change the denominator of all fractions to this new denominator. Divide the common denominator by the old denominator of each fraction. Then multiply this number by the old numerator to find the new numerator of the fraction, and add or subtract the fractions combining all like terms in the numerator. Reduce to lowest terms. Okay, that's a mouthful, huh? Let's just take a look at it and see what this is telling us. Then you come back and read it again and see if it doesn't track. Okay, so we're going to perform the indicated operations. We're going to add 1/4 and 1/6 together. You can't do it. You can do it on your calculator, but to do it here on paper, no, you've got to find a like denominator. So the first thing we have to do is factor those two denominators. When we factor 4, we get 2 times 2. When we factor 6, we get 2 times 3. So we've got 2 2's in 4 and 1 3 in 6. So the lowest common denominator, the lowest common multiple then is 12 to give us a common denominator. So now we have to change each fraction so that its denominator is 12. Well, to make 1/4 into some multiple, to get 12 in the denominator, we multiply the top and the bottom by 3, and we get 3/12. We do the same thing for 1/6. We multiply the top and the bottom by 2, and we get 2/12. Now we can add 1/4 and 1/6 together with these new arrangements of 3/12 and 2/12. When we add them together by inspection, bingo, we have 5/12. So now we can add them together. Can we reduce 5/12 down? No, we can't, because 5 doesn't go into 12 any clean value, so 5/12 stands. Let's look at 1/4 and 6/18, and we're going to subtract 9/24. So now it gets a little more sophisticated. So again, we're going to take 4, 18, and 24. We're going to factor each of those down to its lowest common factors, okay? So 4, 2 and 2, 18, 2 times 3 times 3, and 24, 2 times 2 times 3. So now we have to look at it and find out what are the largest number of factors in all of these. Well, for 24, we've got 3 sets of 2, so we have to keep the 2 cubed. In 18, we've got 3 times 3, 3 cubed, 3 squared rather. So we've got that one. 4, we don't need to do anything with it because we've already got 3 2's. So we've got 2 cubed, 3 squared, which gives us 72. So now 72 becomes the common denominator for all 3 of these terms. So all we have to do now is take 1/4, 6/18, and 9/24 and determine how we can turn them all into a denominator of 72. So 1/4 then becomes a value where we multiply 18 top and bottom. That gives us 18/72. For 6/18, we need to add 4 to the top and bottom to get 72. And then the same thing for 9/24. Now we've got a 72, a 72, and a 72 in the denominator. We can now do our addition and subtraction. So 18 plus 24 minus 27, boom, 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 all divided by 72 gives us 15/72. Can we reduce that? Yes, we can. We can reduce it by 3. 3 times 5 gives us 15. 3 by 24 gives us 72. So now we have our lowest common denominators. So in an example here, we're going to use a power measurement, watts. A circuit consists of 2 components. One component dissipates a 1/2 watt of power, and the other dissipates a 1/4 watt of power. What is the total power dissipated? Total power is the sum of the individual powers dissipated. So another practical application that we use in electronics. So a 1/2 watt added to a 1/4 watt gives us what? 1/2 watt is 2/4. If we factor that up, added to a 1/4 watt, we end up with 3/4 watt. Can we take that into a decimal? Yeah, it comes 0.075. Okay. Improper fractions and mixed numbers. When the numerator is greater than or equal to the denominator, the fraction is called an improper fraction. This is where we talked about the flour, 5/4 cup. You don't use that. So the improper fraction, 4/3, 6/5, 17/12, the numerator is always more than the denominator in trying to handle them. So numbers that have a whole number part or a fractional part then are called mixed numbers. So if we want to change 4/3 to a mixed number, take it out of improper status, we say 4/3 is equal to, take that 1 3/3 out, and we're left with 1/3. 1 1/3 becomes our value. Okay, do the same thing with 17/12. Okay, we end up with 1 5/12. 2 2/3. Now I want to go the other way. I want to turn it into an improper fraction for whatever reason. 2/3 is equal to 6/3 because we have a 3 over 3 and another 3 over 3 in 2. So that becomes 6/3. What's left over is that 2/3, and we get 8/3. Now 2 and 2/3 is an improper fraction of 8/3. Going to do the same thing here with 5 1/4. Okay, so we've got how many 4s, 4 over 4s in 5? Well, there's 5 times. So you can see that we can continue to reduce this or turn this improper fraction into an improper fraction so that we can handle it. Multiplying and dividing improper fractions is no different from multiplying and dividing proper fractions. See, in this case, we don't have to deal with common denominators. We just multiply them together. So you multiply the numerators, you multiply the denominators the same way that you did before. When we multiply or divide mixed numbers, we can change the mixed numbers or improper fractions and perform multiplication and division. So again, this is just like we've seen before. We can massage each of the terms here so that we get a proper fraction, and then we can multiply them together. So we turn this into an improper fraction, and then in the end, we have an improper fraction, and we change it into a mixed number. To add and subtract, we change all mixed numbers to improper fractions and perform the additions and subtractions as we did with the proper fractions. Okay, so here we do have to have common denominators. So we can take the 5/4, turn it into 10/8. We can add them together just like we did before, and then we end up with our mixed numbers 2 and 3/8. Numbers are expressed as fractions, decimal numbers, or as percentages. To change a decimal number to a percent, we just merely multiply it by 100 and add the percent sign. So 3/4 ends up as 0.75, okay, with three significant digits. Multiply it times 100, we get 75%. Okay, 47 hundredths ends up to be 0.470. 47 hundredths, multiply it times 100, we get 47%. Okay, so in each of these cases, making a percent into a fraction into a percent is a fairly easy process. All right, end of chapter 4.